Thanks, Eric. Building officials, thanks. Next group, architects. So we got a good showing of architects as well. Engineers, the mass majority. Are there any others? No others. Okay, no others. All right, with that, I'm done. I'm going to introduce your leader, Eric Richards. Eric and his group put this together. I'll let him introduce everybody. What they worked very hard to put this together, and I'll get out of the way. Come on up, Eric.
All right, thank you. Good morning. Thanks, Greg, for that. It's really great to see so many folks here this morning. I work with Greg to develop kind of these programs for usually our bi-monthly programs. So it's always a challenge to find the topics that are relevant and kind of important for folks. Looks like, I mean, we've got our kind of combined group here. So it's, but appears to be, you know, a good topic that people are interested in. So. Do you want to go ahead and switch to the PowerPoint? Great. So my name is Eric Richards, structural engineer here in Fort Collins with Clark Anderson Partners. Also today we're going to have Mr. Juan Mancha and Mr. Mark Tuesley with the Larimer County Building Division. I'll be kind of talking, you know, from an engineering side. They'll be talking about from the building department side, kind of some of their processes and stuff. And then we'll kind of end the program with Mark Sorensen with JVA Engineers talking about some field observation stuff that he and his firm utilize.
Hey, Eric, if I could just interject.
Yep.
We've got it kind of broken into 3 parts, right? So what we'd like to do is hold questions to the end of each part. So when Eric's talking, if you've got some questions for him, if you could maybe write them down and then we'll address those before we move on to the next topic. Since we are recording this, we're going to pass the mic around if there's questions. So please ask a question from the mic. If you don't, we'll repeat the question so those online can hear it. Thanks.
Perfect. Thanks, Mark. There we go. I think we got it. Maybe. Just got to be a little closer. Okay. For kind of an outline of our presentation today, again, since we've got a variety of folks here from architects, building officials to our engineers, I'm going to do kind of a overview of lateral design, high level, just so that mainly our building officials and architects have an understanding of kind of the process that we as engineers go through as we're, you know, putting together lateral design for a building. Then again, Mr. Mancha and Mr. Tuesley will be talking about kind of the building department's role in it, some of the plan review stuff that they go through, as well as field inspection stuff that the building department looks at. And then to end us up here today will be Mark talking about, again, kind of the engineer's role in the field and some of the steps that they take, that we can take in the field during observations. Some of our objectives, again, is to kind of talk about and look at the complexities of lateral design, what goes into putting that design together, particularly related to our region here with the higher wind speeds and wind loads that we have. And also to discuss kind of the importance of structural observations and structural inspections and kind of the role that those play. And to provide an overview of the building department and, you know, kind of the steps that they look at for some of their plan review, as well as their field inspections. And then identify ways that our industry can work to improve the whole process, working together and making sure that, you know, what we design is getting built. And built correctly. So for kind of a start in the lateral design overview, we live in a unique region here, not just because of the beauty of our mountains and people wanting to live here, but we also have our special wind region here with high wind speeds along the Front Range. Because of these wind speeds, we've got higher wind loads, making our lateral design more unique and challenging because of those wind speeds. And as I'm sure a lot of you know and see, like, our designs are becoming more and more elaborate, kind of pushing the envelope. Owners are wanting to see more glass, more windows, larger openings, garage doors in living spaces that 20 years ago we would have never thought about. Here's a design provided by Arnett Design Studios. Kind of a typical, I don't want to say typical, but a single family residence that we might see somewhere along the Front Range here. We've got some 2-story elements there, large garage, lots of door openings, clear story elements, and again, from a lateral design perspective, create some unique challenges. Here's an elevation view of this particular building. As you can see there, we've got large opening after large opening after large opening all the way across this wall elevation, therefore making a lateral design particularly challenging in this direction. And here's kind of that same floor plan. It's a little hard to see maybe from where you're at, but we've got large opening, large opening, large opening, storefront windows, another large opening. So lots of glass. From a lateral design perspective, makes that kind of challenging to determine what's going to resist our loads in this building. So from a kind of a residential perspective, and in the commercial realm as well, a sizable portion of the Front Range falls falls outside of the scope of the IRC from a prescriptive wind design. Within the IRC, it talks about the prescriptive design is no longer valid for areas of 140 miles per hour and greater in wind speed. So once we reach those areas, we've got to look at other alternatives for our lateral design. Here's a map, wind speed map out of the I believe I took this one out of the IBC. Should be kind of similar for ASCE 7, but highlighted here is we've got Colorado there circled, and then I don't know about you all, but it's kind of hard to see. But the entirety of the Front Range there is shaded, as we are a special wind region here. Here's a Google Earth image, and SEAC has worked diligently to update and maintain a wind speed gust map. And on this map here, we can see the Front Range. We've got I-25 shown, highlighted with the green map. That's kind of where our typical wind region of 115 miles per hour, and this is an ultimate wind speed. Everything east of there is 115, but as we move west of I-25, then we start to get into our special wind region and higher wind loads. The cyan line there moves up to our 125 mile per hour contour. And then the next yellow line, that's our 140 mile per hour contour. And kind of that entire region shaded in red there is 140 miles per hour and greater, and therefore kind of falls outside of the IRC and the prescriptive design methods for the lateral design within the code there. So within the IRC, once you get above that at and above that 140 mile per hour wind speed, it does provide some alternatives. Some of those being the American Wood Council Wood Frame Construction Manual and the ICC Standard for Residential Construction and High Wind Loads. Now, I haven't used either of these documents personally, have have any of you utilized any of those as an option in your designs? Okay, then I guess I don't feel so bad then that I haven't utilized them either. Typically, certainly in the commercial realm of construction, or most generally, anytime I'm designing a residence, I'm using ASC 7 for loading, as well as the IBC, and I'm talking about kind of the NDS, or the another code within the wood design manual. Another alternative is the AISI standard for cold form steel framing. However, I don't know about any of you, but I have not seen any, certainly single family residents built out of metal studs in our area here. Just not commonly done from what I've witnessed. So for this presentation, kind of for the overview, I'll kind of just focus on an engineered design, since a large majority of our front range falls outside of the prescriptive design methods in the IRC, and and this would be applicable to any commercial job you're doing as well. Again, kind of utilizing the IBC and the American Wood Council, we call it the SPIDWIZ, the special design provisions for wind and seismic, kind of the two codes to guide us through that. So as engineers, as we're beginning our lateral design process, we need to determine our design criteria from a lateral standpoint. We're going to look at wind loading, as we've been talking about here, utilizing ASCE 7 code. And again, SEAC has worked and developed a front range gust map so that you can look at your particular job site and apply the wind load, find what wind load to use for your project. Larimer County also has a really great tool, and I think Boulder County might have something similar where you can go on. Larimer County has their wind and snow load map. You can click on your parcel where you're designing. They've got your snow load and wind design speed for that property. And again, I think, does Boulder County have something similar?
I'm just curious, is everyone aware that through SEAC, there's the KMZ file that you can put on Google Earth, and then you can find your wind speed very easily just by looking it up with Google Earth? Is everyone familiar with that? Okay, that's a great tool.
Yeah, if you're not, Greg, maybe we can try and work to send that out. That, as Mark noted, that KMZ file is free to download. It's on the SEAC website. It's pretty easy to utilize. I've done it myself for that image that I had up there. Go to Google Earth. Got to play with it a little bit, but it allows you to import. You download that file to your computer. You can import it and then drop that in there and click on the wind contours. It allows you to do risk category 1 buildings, which is 300-year return period, I believe. The 700-year return period is kind of standard risk category 2 structures. And then if you're doing risk category 3 and 4, it also changes those as well. I know with Larimer County, their wind speed map, everything is risk category 2. They have factors to kind of get you to risk category 3 or back down to a risk category 1. So thanks. Yeah, good point, Mark. That is a great tool out there. I use it all the time. Would highly encourage those designers, if you haven't, to look into that as well. So then continuing with the lateral kind of perspective, if we're looking at seismic loads, not a huge concern here, and something that I'm kind of not going to focus on a lot, but for this presentation, kind of thinking more about our high wind load area. Seismic, again, ASCE 7 and 2 other tools that I've utilized. Structural Engineers Association of California has an online map that kind of similarly type in address or coordinates. It'll give you seismic design criteria. I utilize that one. The Applied Technology Council, or ATC, has a hazards by location tool that you can use to type in your address. Similarly, it gives you kind of your seismic design criteria. Other less common lateral loads that you might encounter could be flood loads, soil loads, or high in the mountains, maybe designing for snow or avalanche loads too. Again, less common, but specialized regions might have an engineer look at that. So broadly speaking, is in a building, wind loads are applied. As wind loads are applied, as you can see, hitting our walls, part of that force is going to go downward into the foundation. The other parts are transmitted up into floors and roofs, trying to push the building over, and then our lateral system is holding that back, whether that's with exterior walls or interior elements. Similarly, with seismic, ground motion is initiated, and then we have inertial forces kind of wanting to push the building over, at our roof and floor levels, and then our lateral elements, the walls and interior elements are holding that back. Regardless of the type of loading, our end goal is to kind of collect those forces or determine how they're applied to the building, collect those, distributed to our lateral resisting elements, and then transmit that down into our foundations. Some elements that could be used for this are going to be steel braces, concrete or masonry shear walls, concrete or steel moment frames. I know talking with Mark Tusley here, again, the more elaborate designs we're getting, large openings and stuff, we're starting to see a lot more steel being put in residential construction as well as our commercial projects. Or another options are cold form steel framed walls, again more of on the commercial side, or wood frame shear walls could be used in kind of what we're focusing on here today. So as an engineer is looking at or a designer is looking at their building, trying to determine how to resist those forces, you're looking at the geometry, how loads are acting, where they're transmitted, and how are we going to resist those forces, and generally distributing those to kind of our walls and floors, and then looking at specifically with wood construction, what walls are available, where can we resist those forces, and are they adequate, do they meet aspect ratios and such. Here's that same floor plan I had showed earlier. Now looking at it from our lateral design perspective in a north-south direction, hope you all can kind of see that. Highlighted walls in red, if we're looking plan north-south here, that could be utilized for lateral resistance. And highlighted it here in cyan. That's going to be really hard to see too, probably, but from a lateral design perspective, some areas of challenge are going to be, we've got a single wall here in the middle of that kind of larger span. That one's going to be working really hard. Over here as well, we've got another wall kind of shorter and not as long. It just, those are working really hard. And we've got, those larger openings in the east-west direction there as well. And, as a designer, trying to figure out how that load is being resisted and transmitted through the building. And here's kind of remind that 3D schematic again of that house. Again, we've got kind of large 2-story elements there, catching a lot of wind load. We've got clear story roofs here. So, it's a lot of work to transmit and kind of cover where those forces are going within the building. There we go. So that kind of leads us then, once we've kind of looked at a building, we're starting to determine what forces we have on it and how we're going to resist those. Then the designer is going to dive into the SPIDWIZ, or the special design provisions for wind and seismic. And we're going to kind of the elements we're looking at are we call them our diaphragms. That's going to be our roof, our floors, and sometimes, or less common, ceilings could be utilized as a diaphragm as well. And then we'll also be looking at designing of our shear walls, or walls either from gravity standpoint, or maybe they're functioning as lateral elements. hopefully they're working as both. That's going to help us with overturning forces on those walls. Here's a schematic of kind of a simple building with a flat roof diaphragm. Kind of same concept applies to homes with gabled roofs and such, but we have our kind of horizontal element here that's collecting loads that are being applied at the roof level here. Those are transmitting forces to the outside of the diaphragm and then being resisted by a bracing element here in the center. Now, one thing to kind of note with this is that, that bracing element does not go the entire length of the wall. So we've got collector elements that are kind of helping grab those forces and transmitting those with design connections into that bracing element. Again, whether those are steel braces, moment frames, or, in what we're kind of discussing here, wood shear walls. Wrong way. Okay. So looking at our wood frame diaphragm design, the engineer or designer is going to look at the sheathing that we have available and pushing the wrong one. Okay, not touching. So whether that diaphragm is going to be blocked or unblocked, the type or grade of sheathing, and then our nails that we'll be using and sheathing thickness. Next slide. All right, here's a table out of the SpidWiz, kind of what we as designers would go to select our capacity and forces for our diaphragm strength. This one is for an unblocked wood structural diaphragm. I'm just going to stand over here, I think. There we go. All right. Then we've got our wood grade or sheathing that we would select, and then followed by the different nails options we have. Here we've got 6/8 or 10D that we could use, and those kind of transmit into different lateral capacities of our diaphragm. So we got our sheathing nails we're looking at. We also have to consider the orientation of our panels. Now the SpidWiz shows or has a graphic such as this showing different configurations of how floor diaphragms or roof diaphragms could be installed. As you can see, we've got load cases kind of noted on there, 1 through 6, and then different lateral capacities associated with those. I would caution, or to be aware, again, how those are oriented relates to different load capacities. And I would say, unless an engineer is going to be very explicit or very detailed in their design, that I've always kind of typically utilize the lower value or more conservative values there, but it's there at an option. So for inspectors and building officials, just to be aware that that could be something that a designer has selected and needs to use. So orientation of our panels, and boy, there we go. Sorry about that. Perhaps those values don't work. We've got some other tools at our options, some high load diaphragm selection tables. And one thing to be conscious of when designing these are that special inspection are required per the code for high load diaphragms. And with that, we've got different nail pattern options that we could select to get to those higher values. All right. That one's we'll work with that. Okay. Here, this is a kind of a similar table. We've got our sheathing and nail spacing over here, as well as sheathing thickness. This one is for wood blocked structural panel diaphragm. Kind of covered up here, but we've got options for different nail spacings now within that high load diaphragm, and much higher values for that we could select. With that comes along some specialized details that are required per the SPID-Wiz code. These are shown in there. So again, for building officials, inspectors, designers need to be aware that if that high load diaphragm is utilized, that these are special details that need to be paid attention to. Some other elements of the roof floor diaphragm that we'll be looking at would be framing size and spacing. If you've got areas where you're exceeding kind of 24, 32 inches on center, start to impact again, those design values. And then we've got to look at kind of the connection now, how we're transmitting those forces out of that diaphragm into our lateral elements or shear walls. And the other kind of pieces of a diaphragm are going to be the chords, which are resisting bending forces in the diaphragm, and then the collectors that I'd highlighted before. All elements that need to be kind of thought through, addressed, and designed. And lastly, looking at deflections within that diaphragm, making sure they're staying within the code prescribed limits for those elements. Now, kind of through the horizontal members, now we're looking at our vertical shear wall elements. And with that, we've got several shear wall types that we have at our disposal. Those are going to be segmented, perforated, or force transfer around openings. And I would say kind of the general selection process is going to be in that order. A designer is going to look at, probably start with a segmented option. If that's not working based on the amount of force or length provided, maybe we're going to go to a perforated shear wall. And lastly, a force transfer around opening methodology. I've got schematics of what those look like to kind of illustrate. So here's a kind of the same elevation of a wall, just kind of generic. This top schematic here is a segmented shear wall design. So the designer is going to grab kind of individual panels within that wall. This one has 4 highlighted. You've got other options. You could utilize these 2. Just kind of, simplifies the design where we've just got single elements, no openings that we're concerned about. But kind of the drawback of this methodology is that a lot of times we've got these red dashes here signifying where hold downs would be. So you've got a lot more kind of elements detailed there. And the second option would be a perforated shear wall, in that, now we're utilizing the entire length of that wall. We're needing only hold downs at the ends. The drawback here is that we have to take reduction values because of the openings within that wall. And then the last one kind of option is the force transfer around openings. And I would say that this is generally the last resort option, because there's a lot more that goes into the design and detailing of these, and a lot more that could potentially be missed in the field. Here we've got kind of shear panel above an opening, on the sides of the opening, and then below the opening, operating in the same manner, where we've got forces transferred, into the top of the wall, resisting our overturning forces. But now we're strapping either at the corners of those openings, or sometimes I've seen that illustrated as it goes all the way across an opening. So just a lot more for a contractor, a framer to keep track of out in the field, and certainly kind of a lot more from a design perspective for us to be aware of and put on drawings.
So Eric, I'm just curious, for the engineers in the room, just a show of hands, who prefers to do segmented shear walls? I would see most of the hands go up, probably, right? Who is comfortable doing the other methods of force transfer and perforated? So I think perforated is the easier of the 2 that I just mentioned. And the benefit to that is you have a lot fewer hold downs, because, as that one picture showed, you had 6 or 8 hold downs versus 2. Yeah. So I would encourage maybe considering perforated. It's not that hard to do. And a lot of the design softwares that we use will easily do that method for you. So keep that in mind. So for those that are online, the comment was that APA has a spreadsheet was it? That'll do force transfer? Okay, so force transfer, I think has come a long way, because when it first came out, it just said by methods of mechanics of materials. It was very, very, very vague, right? So now there's a lot more definition of how to do it. So be open to it is all I'm saying.
Yeah, there are tools out there. I have seen APA kind of advertise that. I've never dove into that and tried it myself, but it's pretty handy. Okay, maybe check it out sometime. So kind of, thinking about our different methodologies with our shear walls, similar to the diaphragms, then we need to be thinking about our sheathing type here. We've got more options within shear walls, because now we have not only the wood structural panels, but we've got gypsum or Portland cement plaster, lumber sheathed shear walls. Again, what I've seen mostly in our area is the wood structural panels. For the outside, sometimes we can get into like gypsum shear walls on the interior of a building. And then again, similarly, selecting our thickness of our sheathing. Same type of table here, where we've got our sheathing material, wood structural panels, plywood siding, particle board or fiber board. Those last two kind of give me the heebie-jeebies. I don't like the thought of trying to resist lateral forces with those, but I know I've torn into a few houses and found those. So, all right, and then similarly, kind of our nail again, 6, 8, 10D. I think Mark, you were talking about. We've got I think the other Mark here, we're looking at kind of the new advent of the zip sheathing or the R sheathing out there. We've got insulation that contractors are trying to drive nails through and stuff. So something to just be considerate of is our nail size and spacing, and kind of being very explicit with what we need and what system is used there. And then again, here we've got different options for nail spacing, again, translating into different shear capacities or values for our shear walls. So it used to be when designing, you could have within the same table blocked or unblocked values. The SpidWiz has now gone away from that. Blocked shear walls are the standard. And if you're wanting to use an unblocked value, which has lower capacities, you can do that, but you just have to take a reduction for that. Kind of our standard framing of 6-inch edge and 12-inch field, and 16-inch studs on spacing. You can see here that has about roughly 60% of the capacity of a blocked shear wall. So from an inspection standpoint, if we're out there in the field, if that shear wall has been designed as blocked, if it's missed for some reason, now that wall has essentially 60% of the value that blocked wall was. So important element there. Kind of the same thing for the shear walls here. We've got our cords, top and bottom plates, our tension and compression members, side elements there that resist those forces. Looking at kind of lateral overturning of shear wall panels there, especially in the segmented design, where we have to design our hold downs for those. And again, kind of our attachment at the top of the wall from the roof or floor diaphragm, and then down at the base into our foundations or floor below. And then lastly, we need to be considering deflections of that. So there's a lot of steps and things to look at in the design of that. Here's a graphic of kind of a standard shear wall construction. Again, we've got our top and bottom plates there. We've got side members for tension and compression, our sheathing on the outside face. We've got hold downs on the ends there, and then anchor bolts in the side. So there's just a lot of parts and pieces of that. So, that's kind of goes through in a real quick, broad overview of the steps for a lateral design. And, thinking about a building system and getting all those forces transmitted from the roof through the walls, maybe multiple floors down to the foundation. These systems are complex. There's a lot to them. So for us as designers, I think it's important that we remember that those folks who are out there trying to construct these and inspect them are generally not structural engineers. So we need to work really hard to be explicit in our details and the design and clear and concise with that. Ways that we can kind of help ensure that we're, doing the best job that we can are through those clear and concise documentation. I know Mark's got some details he'll show in his portion of the presentation later to work on that. But another tool that we have to kind of help ensure that, things are getting built as designed are our inspection and observation processes. Now, structural observations, as defined by the IBC, is when a registered design professional is out there looking at our structural systems for general conformance. And then likewise, for special inspections, are code mandated to look at particular elements and aspects of the building, and whether it's continuous or periodic, but looking at very kind of specific elements by trained individuals for that. And for example, kind of the wood diaphragms and shear walls that I've discussed here. So, in my opinion, structural observations and structural inspections are not one and the same. They're not equal. Structural observations, generally, if I'm out there performing, is a little bit more higher level. I'm not looking at to quite the detail that I would expect a special inspector to be doing. I can look at sheathing thickness. Are the shear walls installed at the locations I have? Are those hold downs there? There could be a lot more depth that I would go into, but I would say generally from an observation, it's a more higher level and not to the nitty gritty that a special inspector would be looking at.
First off, your liability insurance for most of the engineers here will never cover the word inspection.
You're correct.
I do a lot of testifying in a court of law. There's one engineer in particular that was working in Denver. He got on the witness stand and literally got ripped by the attorney. And he's out of practice. He quit because he didn't want to do anything. Observation is what you do, okay? Special inspection is an open book for every attorney in this state and country to rip you apart and do it, because you don't do a special inspection.
That's 100% true. As structural engineers, we do structural observations.
Correct.
It does not replace a special inspection. It is in addition to a special inspection, if special inspection is required.
But many of your county officials or building plan officials right now require that you specify the special inspections that you're going to do on your plans.
So our drawings indicate what special inspections are required, not that we're doing them as the engineer of record.
That's still bad news. And because the other thing,
that's what's required by
on their building official too, told him I don't do special inspections, and he wasn't going to issue a permit. And as I did in Jefferson County, the little foundation compliance form letter, if you read the last sentence in the foundation compliance form, I got that put on the form. It basically, before that was issued, it was a warranty and a guarantee of the performance of that foundation. Now it has a disclaimer sentence at the bottom. The same way goes with this fact that you got to have special inspections on it. No, there's a state provision in the professional engineer's licensing that you can't tell me what to do or how to run my job. So be careful of the word. I do not use the word special inspection or inspection.
Just like when we go on site, when I go on site, we do an observation report.
Correct.
We do not write an inspection letter ever. We don't, to your point exactly, engineers, all of us in the room, we don't do inspections. We do structural observations.
And I used to design hotels and motels around the whole country. You've never gone through an inspection until you've been to California.
Yeah, that's true.
They have a tape with holes in it that are spaced at 6 inches on center. They will literally pull the tape down along the sheathing and nailing. Where you're missing a nail, in other words, the head of the nail is not in that circle, they put a little red dot. And if you exceed more than 40% or 30%, depending on the jurisdiction, they make you re-nail the whole entire thing.
We'll get to that too later, because I'm going to talk about structural observations.
Thank you for bringing that up, and fully agree with your point and to what Mark said. Like, and I've had that drilled into me since early on, that I'm not doing an inspection out there. It's an observation. So,
And every letter I've ever received is an observation letter. It never states an inspection was performed.
right.
And be on my plans as well, as you guys know, I cloud and I put a structural observation letter required to the building inspector. I don't put special inspections.
We've never.
No, we haven't.
Yeah.
Maybe yours, sir, maybe it's happened in Denver, but we don't do that here. We don't do that here. And that's how I teach my plan examiners. Yes, sir.
So residential foundation. That's just an observation. That's not
That's correct.
inspection. Okay.
Yeah, that's correct. We accept your letter as written. It may say foundation inspection on the permit card, but an observation letter is what's actually entered into the record.
If everybody would use the mic, it will help the recording. I'm sure you've all been in Zoom or WebEx where the people in the audience aren't using a mic and you wonder what they asked. So I'd appreciate your help.
Thank you for your comments, sir, because that is kind of one of the things that has spurred kind of the desire or need for, our presentation of this nature, is to talk about what is the difference. I know we worked with the county. They've been working diligently to adhere to section 17, is that right, of the IBC for, special inspections.
1705.
Yeah, we as SEAC, have been helping them kind of develop the language so that we as engineers of record aren't being requested to sign something to say we certify or we've inspected something. So thank you for your point on that. And again, kind of to my last comment up here is, don't assume, because again, structural observations are in our world, in our mind, are different from inspections. They are not one and the same. Now, are we as registered design professionals, allowed to operate as special inspector? The code does permit this, provided we are qualified, quote unquote. What constitutes qualified? I don't know, to your point there, that's a good question. Are there certifications, education and stuff? I would say if I had to, I could operate as a special inspector for foundation elements. I could look at rebar. I could look at the size and spacing and clearances and look at that. I'm not qualified to look at welds, high strength bolting. I don't have I don't have that certification background or anything. I could not operate at that. Here in kind of our wood framed that we're talking about, could I be an inspector? I probably have those qualifications. I could look at nail sizes. I could look at penetrations. We could look at sheathing sizes, but there's a lot of parts and pieces there that if I were to operate as an inspector, I'd have to have a lot of checklists and processes in place. And kind of, to Juan and Eric's point, and maybe what other jurisdictions, again, kind of the thought and intent was to make sure that our code officials aren't expecting us as engineers to be performing observations and, inspections, because we are in our minds, we're always doing observations, that those are not equal. So are there liability issues or restrictions on insurance policies to do that? I haven't got into the insurance world that much to know, but I've talked to Bob Strine, who is a insurance broker for a lot of engineers up and down the Front Range. Speaking with him, and he'd spoken to our SEAC group a few months back. I don't recall when, but sometime this year. And I had a conversation with him asking about it. And he said, to his knowledge, that there are generally no restrictions on your insurance policy that would not allow you to operate as a special inspector. But he did caution that if you are going to act in that way, that you work really hard to put the proper processes in place, that you've got checklists and procedures written up so that you and your staff are looking at every single thing. So I'm not advocating that that we try to operate as a special inspector, but again, it's permissible by the code, and there may be certain instances where you are the most qualified individual to do that. So if you're going to operate in that manner, I just caution you to kind of make sure you've got the right processes again in place. Inspector qualifications. Now, the code requires that, whether we're looking at like third parties, that these qualifications be submitted to our building officials so that they can review those and verify that they kind of meet a minimum level of standard. Do you as the design professional ever see these? I know that I personally have not. I've not specified those and not reviewed those. And I guess, just to kind of pose a question rhetorical to the group, like, is that something that we should consider or get into? I don't know that I want to dive into that, but is that something that we need to think about and as a group and look at, maybe something for us to consider. So when are special inspections required? Kind of, again, speaking of our wind region here, per the IBC 1705.11, and wind exposure category B and wind speed at 155 miles per hour or greater, special inspections are required. City of Boulder falls within that, correct? Yeah. Excuse me. Likewise, exposure category C and wind ultimate at 140 miles per hour or greater. Again, a special inspection is required for those structures. Now, IBC does kind of have some exemptions. Light frame wood structures designed per the IBC. A lot of these are kind of extraneous structures that are, would be kind of small additions that are not, that don't cause life safety concerns, or when permitted per the IRC, which I found that kind of interesting because the IRC doesn't, the prescriptive method doesn't work above 140 miles per hour. So you have to kind of use those other two documents if you were going to design for that. Okay. And then section 1705.11.1 for structural wood, periodic and special inspection is required for kind of our lateral force resisting elements, shear walls, diaphragms, hold downs, drag struts, things of that nature. Now the code does provide an exception if we can design our structures, if we're outside of the 140 miles per hour, and you can have shear wall spacing and diaphragm spacing at 6 inches on center and 12 inches in the field, that special inspection would not be required. Next. All right. So that got me thinking that, as I drive east of Fort Collins, or even, I guess, within Fort Collins, anywhere east of I-25, the Greeley area, Windsor, East Fort Collins, we've got tremendous amounts of multifamily residential construction going up. We've got 2, 3, 4-story buildings being constructed. And, if you can design those from a lateral standpoint, that your shear walls are at 6 and 12 for nail spacing, and we're outside of that 140 miles per hour, special inspection would not be required. Now, are we okay with that, or would we want those to have some level of higher level of inspection? Now, the code does permit us as design professionals to require it as we see fit. And kind of, again, what's another driving factor for wanting to kind of provide a presentation of this nature is that a lot of those multifamily projects, we've got corridor walls, we've got demising walls that are, you know, a good use of an interior gypsum shear wall. Now, the kind of challenge with that, as well as potentially a double-sided shear wall, is that the sequencing of that. Walls go up, floors go up, roof, everything's covered. We get the exterior sheathing on, inspector comes out, looks at all that, everything's good. Contractor's moving forward. Well, I can't install those interior gypsum shear walls or sheathing till I get my electrical run through there and everything. At that point, we as engineers are kind of done coming to look at stuff, and you know, unless we've really kind of thought through it and everything, you know, we're not out there looking potentially at gypsum shear walls. Or if you've got, you know, kind of a high load element that is double-sided, again, you know, that layer of gypsum or sheathing is coming on at a much later date when we're kind of done and out of there. So from a inspection standpoint, like, I want somebody out there kind of verifying that nails or screw spacing is in there, at the right pattern and spacing. So one way to kind of address this, again, was that we as design professionals can specify special inspections for that. I worked with Blake, we developed a special inspection table kind of specifically for this type of instance, you know, not only to address exterior wall sheathing, things that should be looked at, but to ensure that a third party is coming out there to look at those interior gypsum shear walls. So we'd kind of, that's hard to read if you can read that at all. But, you know, kind of walking through and addressing the elements that we specifically wanted to have looked at, i.e. in particular, like these interior gypsum shear walls, as units are being finished, to make sure an inspector is out there looking at any drywall that we were using for the lateral system to make sure that it's being looked at and reviewed.
So I'm just curious about that. Blake, do you actually put those on your drawings, or is it the statement of special inspection? Yeah, we do as well.
I know, kind of discussions with you, Mark, you kind of avoid gypsum shear walls. Is that correct? Or would you use those as part of your design
I
process?
prefer not to, but designing in Boulder a lot with really high wind, I don't want to count on gyp. You're allowed to count on, you know, exterior plywood and gyp if it's wind, and sum them and take the sum of both. But I'd rather just count on the OSB and go to a tighter nail spacing if that's what I need. And in some cases, I have to do double-sided plywood. And again, that's a sequencing thing where I have to go out and look at the exterior sheathing. Then they do all their electrical, their plumbing, they get their roughs all done, and then I have to go back out and look at the interior as well, prior to rock. And framers hate double-sided plywood shear walls.
Agreed with that. So now, in talking with Mark Tusley here for Larimer County, I know that Larimer County is huge, as is Boulder County. We've got a lot of remote areas, and you know, it's hard to get out there to review a job site multiple times. I'm thinking if you're north and west of Red Feather Lakes up in the Cherokee Park area, you've got some owner who wants this big, beautiful house built, and to get out there multiple times, it's a lot of time and effort to windshield time to get out there and do that. And it sounds like you're kind of getting away from that, but I know that a tool you would use is an affidavit for the contractor to kind of verify that they've installed sheathing or sheathing and nailing per the specifications on an engineered plan. And I'll let you kind of speak to that here a little bit, kind of where you're at with that. But again, just things to kind of be aware of, like, are we as designers okay with that potentially a homeowner or a contractor is just signing an affidavit that, yes, I put that sheathing on, it's the right thickness, the nails are at the right spacing, yada, yada, yada. Just things to be considerate of. Here's kind of the look at those affidavits that the county has on their website. Again, I'll let Mark and Juan speak to those when they get to that a little bit. What about other limitations that exist within jurisdictions? Do we have anyone from the city of Fort Collins here? Yes, sir. So my understanding is that does the city, will you inspect anything, or I guess I back up, limitations that are anything over 2 stories, that will the city inspect or will they not inspect that? Not for shear. So up to 2 stories. Right, that's, yeah, again, that's just a limitation that the city has. So things that we as designers need to be aware of and considerate of, and making sure that we've got, got those inspection tables in place that, so that someone is out there looking at those. And other elements, whether it's within a jurisdiction or a special inspector, a lot of, certainly jurisdictions have risk management in place where they don't want their inspectors up there on a 612 roof, climbing around and, looking at that, without, they have to have fall protection, a lot of processes in place. So, just again, like, are these things, are we getting those looked at? And if not, are we okay with that? Again, our multifamily residential projects, 3-4 stories, if the city is not able to look at that, are we having, special inspectors out there? Are they out there on a boom truck looking at nail spacing on, 3 or 4 stories up? I don't have an answer to that. I don't know if that's the case, but, things I just think we need to be consider and maybe have a conversation about. And that's kind of why I wanted to bring kind of code officials and inspectors in here together to kind of see where do those limitations exist, and do we have gaps that are not being covered? So with all that, I would just like to encourage specifically our designers to get out there, perform those observations, and get your eyes on a project. And if we have particular elements or areas where it's a really complex design, different things that maybe we need to look to specify special inspections, use that as a tool so that we have a third party out there, somebody else looking at it. If we can't get out there, as I was talking, most engineers, I think we've got a lot of 1, 2, 3 person shops that we don't have the resources to be out there looking at multiple units and doing half a dozen to a dozen site visits to job sites all the time. So, maybe think about using special inspection as a tool to kind of help ensure that we're covering our bases there. And hopefully contractors don't feel like we're looking over their shoulder. Hopefully they're willing and want to see us out there on the job site to help make sure that they've interpreted things correctly, that things were built properly, and that things are in alignment of what they should be. So I've blabbed enough at you, so that kind of concludes my portion of it. Are there any particular questions at this stage? And if not, I'll transition over to.
So just a reminder, if there's a question, raise your hand. Greg's got a mic and I have a mic.
So thank you for the rundown. As a structural engineer, I am constantly thinking through, we do a lot of renovation projects, and I'm thinking through future-proofing my designs as I'm designing new construction. And I have used gyps sheathing for shear capacity in existing, just trying to get the lateral system to work. But in new construction, I'm a little concerned about that, because how do you communicate to, say, a future contractor, architect, engineer who comes across the project and needs to look at possibly removing a wall? How do they know that that was part of the original lateral system without, say, existing documents dictating as such?
That is a great question.
I would say that it's a great point, and I agree 100%. And that's why I typically would want to use a plywood shear wall, because when they dig into a wall to do a remodel, if they hit plywood, they might at least think about.
Exactly.
There's a reason why this is here. So that's why I prefer to use plywood, even if it's not a super heavy loaded wall, if it's important to your lateral system.
Yeah.
Yeah.
Hopefully you paint on it every 5 feet, right?
Yeah, that's a great point. I mean, you'd hope that maybe those existing drawings were around for whoever might have to do something in the future, but yeah, it'd be hard to count on that. So that's a great point.
Just gotta do a redesign of the structure, especially
Right.
remodel.
Right.
You gotta do a redesign of it, and if you have to, then you
Mhm.
double layer.
That's a great point. A
Wall.
great point about having to do a redesign every time there's a renovation project, but how many times are architects removing non-load bearing walls, quote unquote, and not engaging a structural engineer when it's a shear wall and they had no idea? Yeah.
And they've never built per the drawings.
Of course, of
You're
course.
giving us all warm, fuzzy feelings there. Any other thoughts or questions? If not, I'll turn it over to.
Yeah, what recurrence interval maps do you use for serviceability?
Great question. Generally, I had started with just using the 700-year mean return interval, but through my learning and education, the code permits us to use, does the 50 year, is it 50 year for that? Again, kind of looking at serviceability before was using that 700 mean, but the code does permit us to use a 50-year mean return interval, which is part of that kind of the SEAC wind speeds on there that you can look at those and utilize that file and kind of there's also documentation on the SEAC website that you can use as well, not kind of the interactive tool, but a hard copy. So
And kind of along with that, I'm sure you're all aware, when you're looking at out of plane deflection of a wall, you get to use a reduction. It used to be what, 0.7, now it's 0.42, and everyone's like, why did it go down so much? Right, because that's 0.42 on an ultimate load, which is basically 0.7 times 0.6.
Can you explain what a return interval is?
That would be another 2-hour presentation. So it's statistics. It's a mean interval based on the recurrence. So a 50-year is it's a 50-year interval. It's a chance of it happening is every 50 years, but that doesn't mean it will happen only once every 50 years. You could have 2 50 years in 2 consecutive weeks even. So it's just how likely the event is to happen.
There is some factor in
So those mean intervals that we were talking about is if it's an occupancy 2, so a house, right? It's a 700-year event. If it's an occupancy 3, so a school, then it's a 1500-year, or an occupancy 4 is also 1500 years. So the more important the structure is, the stricter the criteria is that we have to design. Yeah.
We don't have to get too far into the weeds on this, but with, new energy codes, we're seeing this massive uptick in continuous insulation on walls, and obviously like Huber's zip product with R sheathing. Just curious, aside from reduced capacities and like nails, like special nails for that, Huber's got some stuff buried in their literature about like 0 tension capacity in their zip panels for tying wall plates down to studs and things like that. And I'm just curious from everybody, like how this is being approached. When things are getting spec'd as zip R, are we double sheathing stuff? Like I've seen a lot of projects where like, hey, let's sheath it in OSB and then put zip on. And it's like,
I have done that because I needed, and I'll talk about it briefly, not in my part, but zip R, architects love it because you get your water barrier, you get your continuous insulation all in one thing. Structural engineers hate it. No, we don't hate it. There's such a reduced capacity of it that the 1-inch insulation, the R6, I think it is, that the highest value we're going to get from that is from the lowest 6-inch nailed OSB shear wall. And a lot of times that's nowhere near what we need. So I did have a multifamily project in Boulder, super high wind. I had them do OSB on all of the shear walls, and then they came back and they did zip bar on top of that. Now that's expensive, but they got their water membrane barrier as well as their continuous insulation.
What do you do for tying things down? You know, obviously trusses are clipped to top plates.
I've got
Normally
some
we're like-
details that I can share.
I'm just curious,
Yeah. And if there's more questions, we can take about, I'd say 5 more minutes for this part, and then we'll have to move on. But if there's any more questions. Yeah. Do you have them? Okay.
Yeah, so Larimer County lets you use a altitude correction factor, 0.86, I think.
Uh-huh.
And I was wondering what everybody's thoughts were to kind of use that on the V side of the equation, apply it to the wind speed. You have to manipulate it a little bit, but to try and like, if you're in a 150 mile an hour region, use that altitude correction to kind of back it down to an equivalent like 138 or something, and be able to use wall bracing.
It allows you to reduce your pressure. It does not allow you to reduce your design wind
Well,
speed.
I think you would take the square root of it, apply it to your wind speed. Because if
Right,
you're
but
allowed to
but that
reduce the
altitude
pressure-
adjustment factor, we use it all the time at JVA.
Yeah.
Because you're designing for lower loads, but it doesn't reduce your ultimate wind speed from the zone that you're in. It reduces the pressure that you're designing to. So it's not a loophole to say, I'm at 141, I can get down to 138 and design to the IRC. That's not the intent of it, and you cannot do that.
Okay.
Any other questions? All right, I think we're gonna turn it over to Juan now. You want the mic? All right, everyone stand up. Reach high. Yeah. You want this?
Does this work?
Yeah.
Yeah, it works, yeah.
Grab this here.
Yeah. I know I am. I forgot to bring my drink down.
There's water.
Want some water?
Just a little bit. Yeah.
Oh, no problem.
Yeah, my won't. As long as your guys' stuff, yeah, mine's like 10. So yeah, mine's probably 10 minutes.
And you got the clicker?
I got the clicker. With the questions and answers, I'm sure that I might go far a little bit, but. So what I kind of targeted, you still have like 55 minutes, so I thought as long as we're done by 9:55. Sure. I just gonna get some more about it. So, everything.
All right, I know that some people took a break for a pause for the cause, but we're gonna try to get started here again. Feel free if you have to go in and out, you're welcome to do that. But we're gonna turn it over to Juan now.
Morning, everyone. So here's my checklist for all my plan examiners here for shear wall review here in Larimer County. Uh-oh. So the first thing we verify the shear wall plan design for the correct design criteria for the site. We verify the wind, snow loads, wind exposure, C, which is in our local amendments. I mean, if the site is actually B, we'll take a look at it and say, oh yeah, the site is a B. And the correct seismic zone. Also, I've been noticing some stuff too missing, for instance, the soil's bare capacity. So that's another thing that needs to be on the plans. must identify the type and location of all shear walls in the plans, interior and exterior. Have a table or general notes detailing how the shear walls need to be constructed interior and exterior, to include the thickness of the OSB or plywood, the type of attachments, including blocking, and the spacing of the attachments, the fastening. Are any hold downs required at the end of the shear walls? If so, their location, type, required fastening, strap, bolt, epoxy of hold down should be identified on the plans. If the prescriptive method is being used, all the prescriptive design requirements must be met, including all requirements of the 2021 IRC section R602.10. As stated before, a lot of the work's being done in the high wind area, so most of the stuff is being engineered. I rarely see prescriptive, and for instance, when I have a homeowner come in, I'll ask them, they have no idea how to do the prescriptive methods. Like, well, you probably have to get a design professional to help you out. So the maximum spacing of the walls must be identified in the plans or provided on a table. And most of you folks that I work with here, I see that. So it's pretty easy for me to find it, and my plan examiners. Portal frame details, framing location must be identified on the plans. If one of the prescriptive bracing methods is used, the thickness, fastening, and space shall be shown on the plans. And here I have right here, the prescriptive method is only applicable up to 140 miles an hour, wind speed, exposure B. Any locations at or above the 140 miles per hour wind speed must be designed per the American Wood Council Wood Framing Manual, special design provisions for wind and seismic, which is SPIDWIZ, or must be designed by a Colorado registered design professional. And right here, that right there is our map, and I have it on the next page. Here's our wind speed map. We have that on our website. And if you have any questions on it, let me know. I know a lot of you guys use that. And this is from Mr. Benjamin. He gave us this example. Here's an example of a shear wall plan. And this is what we're looking for during plan review. Now, some of you will give me, and this is just me, and I think I have Chris here as well. If you give me like exterior sheathing and you give me the nailing pattern, I would allowed it, because in the past we've allowed it. But this is what we're looking for during our previewing of a plan submittal, something like this and stamped by the engineer, architect, or record. I think that's all I have. So here's Mark's information, and he's going to be coming up next. And here's my information if you have any questions or want to talk about anything. That's it for me. So Mark, do we want
Are there any specific questions
for me? How you doing, Mr. Benjamin? Yeah.
I use the addressing on your maps to get my wind speed, and I had a truss designer use a lower wind speed, and I called him on it, and he pointed to your interpolation table. You accept that, correct?
Correct, we do. I mean, they have to start at, let's say, for instance, 100 pounds per square foot, 171 miles an hour. If it's 100 PSF, they have to start at that 100 PSF and show that they interpolated it. I have a little cheat sheet how to do it, but I mean, most of my plan examiners understand, like, yeah, they can interpolate, but they need to start with whatever the ground snow load is, and then show interpolation, and then show any reductions you've taken per ASC 716.
Same thing with these maps. These are based on the SEAC contours, right? So some jurisdictions, they say, if you're in that yellow, that's what it is, right? But what SEAC tells you is that it's linear interpolation between the contours. So just because you're in the 140 doesn't mean that you're 140. If you're closer to the 150, you might be 148, right? So just what I do in Google Earth is I draw a line and I see how long it is, and then I just do the linear interpolation that way by similar triangles. It's super easy.
And the truss companies are pretty good. They'll start with a PG of, let's say 100 pounds, and then they say they'll interpolate. It'll even say interpolating and whatever it is, 79, whatever they did. So most of the time they're pretty good at that. So I mean, I don't have too many problems with it.
Just to clarify one thing, we allow interpolation if there's a design professional involved. So, as long as one of you guys is looking over it. If it's a homeowner doing the prescriptive, then we don't let them interpolate.
Good job. Are there any other questions for the building officials?
I'll turn it over to Mark.
All right.
And after Mark's done, if there's I know there's other building officials here for other jurisdictions, feel free to chime in if you guys look for something else or have a different point of view on it.
And one more thing, I did bring our handout for brace wall design there. So if you guys want to take a look at it, I brought about 26 of them. So feel free to take a look at them. Sometimes, like I said, I hand them to homeowners. They have no clue what I'm talking about. But yeah, feel free to take a look at them. All right. Thank you.
Hey, good morning, everyone. So I see a lot of familiar faces. I probably know most of you from the documents you submit. Shear wall inspections, we don't get involved in a lot of multi-story in the county. It's almost all custom homes. And with those custom homes, there's a lot of shear wall requirements. We were talking about what we mostly see. We see the segment and design probably the most, up to 40 hold downs in the foundation. I mean, that's something where we're actually notating on the plan, highlighting, because there are so many hold downs on interior shear wall as well as exterior. But that is, I'd say 90% of the design are using the segmented design. And I won't say it's mostly Simpson callouts, but it is. So we're not supposed to say that, right? Most of what we see on the hold downs is improper nailing. Guys are putting in 1.5-inch Tico nails. They're not going per the Simpson chart. We see that on everything, right? Strapping and everything. If they interpolate down every other hole, I'm not talking that they do that on hold downs, but we see a lot of narrow walls and shear walls with double bottom plates where they didn't embed the anchors at the right depth. So what they do is they drill a hole through the top plate and then screw it just like it's a typical anchor to the bottom section only. Doesn't do a lot of good. So they have to come back in and drill and embed a 10-inch or a greater anchor and epoxy it into the foundation. It's kind of where you guys were talking about inspection versus observation. We can only observe what we see. We're not there to inspect every single hole. Do we see them put the epoxy in if it's got the plate on top? We usually don't. So that's just like we would do on an as-built. It's what we can observe is all we can look at. I'd say the most problems we run into are over embedment. And I already spoke to Eric and Mark about the new energy code is going to rule the building code. The more insulation, the greater values. We're going to start running into, shear with the zip R panels. I know some of it's rated for shear, like they were saying, but you have to take such a reduced amount. When they do that, the attachments are so close that they're blowing out all the edges. So that's something for you guys to think about. Anywhere where there's a seam and they're putting them at 3 or 4 inches, they're blowing out every third or fourth one. And we're having to go back in. They're having to put in more nails. We don't look at every bit of exterior shear wall. We look at the hold downs prior to concealment. We look at porches and porch structural, but we're not tearing off the Tyvek. So that's why we have the certification form that they're allowed to fill out. We're basically spot checking. What we're seeing more now, though, is because they're using the zip sheeting and they're not covering it. We're really noticing a lot of over embedment, improper nail spacing. They're signing it off that it was per the engineer design, or let's say design professional, and it's not. And so we're working on, and I've talked to Eric about this, probably going into an exterior shear wall period along with the hold downs and porches, no longer allowing them to cover. We're not going to look at all the sheathing. We're not going to look at roof sheathing. We're looking at anything on the exterior walls. Interior shear, 9 out of 10 houses are done with drywall. They're not done with OSB. We see them, and you're right, trim carpenters hate them, electricians hate them, you know, things like that. But it is almost, like I said, 90% of the time, we're seeing it done with drywall with blocked edges. Eric and I just, you know, talked about that. How many remodels do we do? How many times do they take out a bearing wall and put in a beam because they want to open the project up? They want to open floor plan. We don't know that that was a shear wall. We're not going out there doing destructive testing to see before we issue a permit. We're going out after the wall's already been torn out and a beam's put in. So that's something we might have to address in the future, especially if it's anything in the last 20 years. I mean, prior to that, when I was building in the early 90s and stuff, you were still doing lead-in bracing with blue Dow foam for OSB 4 feet from the corners, right? Celotex on your gable ends and stuff like that. And of course, we don't see that anymore, but thankfully. Interior shear walls, we see the most errors on those, not blocking the floor correctly, not reinforcing the webs if they're using I-joist, not blocking the trusses up above correctly, improper nailing, hold downs. We'll go out to look at a hold down strap and it's nailed through the OSB and nothing else. There's nothing there, literally. Or a framer put in a block 3 feet tall and nailed into that, but it doesn't go anywhere. It's just, you know, they don't understand the concept of what they're putting in. They're not trained. They've never seen a wood construction manual. So I have a nephew. I went out and he's a framer, owns a company, inspected his house. Inspected his house, had 30 something items on the framing. So that weekend we had some family get together and I took him a wood frame construction manual. He's like, "What's this?" I said, "If you don't know what it is, you better read it." Because they only know what the last person that taught them. And if you're not having somebody continually teach you, there's no continuing education. It's you and us that are catching all of this. And then, of course, they always have a question. Well, why do I have to do that? Why do I have to do that? We should carry a truckload of these manuals and say, "Here you go. You know, here, we're going to give you a test on that." I already went over exterior. The zip, when we were bringing that up, we were noticing they're using a typical 8D on a zip panel. Well, you don't have the embedment that you used to. Like I said, we see Tico nails on hold downs, not 16 commons or whatever it's called out. So with shear walls being so prevalent today, and you could see from our wind speed map, we're up in the 190s. So if it's something my inspectors don't feel comfortable looking at, we always refer to the design professional. Most of the time that's decided at plan review. And of course, first thing we look at is what did you require on the plan? If it specifically says you guys want to come out, you girls want to come out and look at it, that's exactly what we go by. Any variation from your design, we're having them refer back, and you get that a lot. They change out something, we're referring them back to you. We're not going to authorize something in the field that we're not qualified to change the design on. That's not what we're here for. A lot of times you'll get, you know, you may go, "Oh my gosh, that's so common sense." Well, we don't want to take on the risk, and we don't feel our knowledge is capable of overriding what you've written in your plan. And so what may seem simple to you, and it's like, of course that works. We just want an acknowledgement from you, because we don't want something to happen down the road and we assume something would work and it didn't, but we put our name on it. You know, that's not the way we run business. So anybody have any, oh, and we don't do multi-story, so I can't speak on apartment buildings and stuff. I've been here 7 years. We've never done an apartment building. Like I said, I've also never stepped into the same house twice. As you can all attest, anything in Larimer County that's a home is generally a custom. It may be a semi-custom for the builder, but for us, it's a custom because I've never seen it before. So we're very in tune with following the design and being very looking for the description, looking to be told the extra design factors on these because they're never the same. So your attachments are great. We need to have tables. If you don't think a table, we'd rather have a table there and not need it than not have the table. Okay, so any questions?
And just to clarify one thing, I think you meant we don't do any multifamily rather than multi-story. I mean, we
No,
see
I'm
multi-story,
sorry. Yeah, multifamily.
We get very little of that.
Yeah.
So this is for both building officials. How often, if ever, do you see true special inspections on residential projects? And part B would be, if you have a steel moment frame that's outside of the scope of the IRC, technically Chapter 17 requires special inspection on parts and pieces of those moment frames. Do those ever actually get special inspected?
Yes, so moment frames every time. That's a special inspection requirement we developed years ago, that if it has a moment frame, the engineer is required to look at it.
Let me interject. If it has a moment frame, a special inspector needs to look at it, because any full pen weld is a UT certification.
Yeah, and that's
So
what
it's not a visual inspection. There's no way an engineer can sign off on any moment frame.
That's my point. It goes back. That's my point. It goes back to the whole conversation about special inspections versus structural observations. And that's kind of a tough conversation to have with a framer.
Our drawings make it, and I'll get into this. I'll show you some examples from our drawings, but I didn't go into moment frames too much because it's about wood shear walls. But yeah, I mean, anytime there's a moment frame, that has to be inspected by a certified welding inspector, ground or somebody like that who has the equipment to do those ultrasonic tests.
And we did just change that, by the way. Oh, go ahead.
There's one more and then we'll get to it.
One thing that we're finding during our observations is they're using the wrong nails for typical OSB shear walls. They're using too skinny and too short of nails.
Yep.
How often do you inspect the actual nail that they use for these attachments?
Well, that's what I was saying on the exterior shear. It's just a spot check when we're doing hold downs. We allow them to tie back in so that the home's protected as soon as possible. Now that we're seeing the zip R sheathing and the wrong nails being used, or they're using a different shaft diameter of nail than what's required, and so it doesn't have the shear capacity.
So
that's why we're revisiting this. And to go back, sorry, on the moment frame, that's always required. Field welding is always required by us. We've just now changed our code. Instead of saying the design professional, that a certified welder, third party, is required unless it's a factory supplied weld. If it's delivered all welded together in a factory, then we do defer to the design professional. But if there's something that we're requiring that you're not comfortable with, or that we need to change our process on, then we should discuss that.
And technically,
Thanks, Mark, because that was exactly to my point on a bolted moment frame where you're depending on factory welds that have already been inspected.
That's right.
So, yeah.
And we don't carry a torque wrench or anything. That's why we don't want to, certain things we don't want to sign off on. So,
and just because it's shop welded doesn't mean that it's certified unless they're an AISC certified shop.
Correct.
There would still be independent third-party inspection required in the shop if they're not a certified shop. Oh, you're talking about, so we're talking about two different things. We're talking about I'm talking about an engineered design moment frame, and you're talking about a pre-engineered Simpson. That's totally two different things.
Yeah.
So based on your comment about how things were built back in the 90s, I would guess like shear wall inspections weren't a thing back then. Like when?
No, well,
when did this focus? Like when did this shear wall inspections become like more stringent, more so a requirement?
Not until into the 2000s, I would assume. I mean, we were always doing the 4 foot, the lead-in braces with 1x4, the steel strapping. The OSB, excuse me, the Dow foam, that kind of went away, starting with your custom builders and working its way down. When that was actually required, I don't think it was. I think people are still out there building like that. We don't deal with a lot of the bigger box builders, the track home builders, so I can't speak to that. We started changing that just out of quality. As a builder, it wasn't really required to do that. We just started doing all of our homes OSB because you know what a house looks like 10 years later if you have blue Dow foam, or the guy's over embedding his nails and you can see that dip on everyone. Stucco, and I would say stucco and your phony stone cladding is also what pushed away from all of that Dow foam because they can't apply over that. It's not allowed. And they're not just going to do the first 4 feet of a house with OSB and the rest out of Dow foam. Engineering, I don't know, you could speak more to when that really became a lot more prevalent with the hold downs.
I would say as the codes get more and more complicated all the time and the wind design gets more and more complex, that's when we've actually, back 30 years ago, people didn't even really look at the lateral design.
That's right.
Now they have to.
And the Simpson book used to be a 20-page pamphlet, and now it's a 1-inch thick catalog. Yeah, when everything was fixed, no matter where we built, if you're down here like Weld County, most of their wind speeds are the same. It wasn't until I started actually going in the mountains, I started seeing a lot more of this. I built mainly on the Front Range, from Berthoud all the way to Owl Canyon. It was a pretty standard. So we didn't have once in a while on especially these multi-story when they started getting away from the balloon framing where they would have this floor to floor attachment. So
I think we need to move on to the next.
Yeah, just one more.
Yeah. Is there any push to get a regional building code established up in northern Colorado, somewhere to El Paso, versus having several counties and towns and cities?
He could speak on that more than I could. Thank you.
Not from building officials, because in this state, it's sort of still a local control state and people like doing that. And we did try to at least adopt, if everyone would adopt SCAC's most recent design criteria along the Front Range for wind and snow, that would help. I wouldn't be surprised if there wasn't a statewide legislative effort to push that, because now there's a state electrical code, building code, minimum energy code, electric ready code. There's gonna be a state minimum wildfire code in 2 years. So it's pushing it towards, I would not be surprised if they said, okay, we're gonna have a statewide building code, but right now, there's no huge push for that.
All right, thanks, Mark and everyone. My name is Mark Sorensen. This is the most interesting part of the presentation. No, I'm kidding. So what I'm going to show is just some things about structural observations, not structural special inspections. In answer to your question, you asked about the diameter of nail and all of that, right? The new SPID has moved away from, it doesn't say 8D anymore. It says the diameter of the nail, and they are also now specifying the head diameter of the nail. So I would encourage all the engineers to start looking at that and then update your drawings. Don't just say 8D, or if you do say 8D, make sure you have a table on your drawings that defines exactly what an 8D is when you're calling that out. So just a brief overview. I'm from JVA. I'm out of the Boulder office. We have 5 offices. Paul is here from our Fort Collins office. Another colleague of mine, Brian, is with me. I do a lot of work in the city of Boulder. The city of Boulder does not look at any of the structure. So they require the engineer of record to write a final compliance letter at the end of the project that we've looked at X, Y, and Z. So we're looking at everything from footings to shear wall nailing and everything in between. So when you're looking at the lateral system, which is what I'm going to focus on, is you've got to make it clear on your structural drawings what you want them to build. And just so everyone knows my background, I was a carpenter for 6 years before I went into engineering. So I know how houses go together, and I know what framers like to do and what they don't like to do. So try to think of not means and methods, but make it as simple as possible for the person in the field trying to install it, right? Because, and don't be so rigid if they propose something that will work that you haven't thought of, be open to it, is what I would say. So sheathing, you know, you've got your rating. Edge blocking, because everything is pretty much fully blocked for shear walls, right? You've got your nails, you've got the spacing and the depth of the nail, and then you've got all of your hold downs. So this is just an example of one of our plans. I know you can't see it very well. The next slide will kind of zoom in on it, but we do things differently in our different offices. I'm not saying that this is the one way to do it. This is how I prefer to do it. For smaller, simple houses, you can definitely indicate the shear walls on the framing plans. This example right here is an actual shear wall plan. On the shear wall plans, we have our hold down schedule, our shear wall schedule, and some diagrams of how we want them to put it together. So this is just a blow up of that plan. So you can see we indicate, and you can't really read it, but SW6 means that we have 6-inch nailing and SW4 is 4-inch. So that's kind of a nomenclature that we've moved to. Makes it easy for us when we're in the field that we don't have to go and say, oh, which shear wall is this? And then typically the little symbol that we have, the point of the shear wall symbol points to the side that we want the sheeting on, if it matters to you. All we care is that it's on one side, if it's a one-sided wall, right? But something to think about too is if it's an interior wall that you're putting it on and you've got perpendicular partitions coming into it, they're going to want to interrupt that plywood. So you better have a detail that shows them how to do that. Foundation plan. I said I was going to focus on the lateral system, but we indicate the hold downs on the shear wall plan and the foundation plan. I don't know how many of you have gone out into the field to look at a foundation and the concrete guy has one page, right? He doesn't have the full structural set of drawings. So we used to just indicate with a little diamond and say with a note that said, look at this sheet. Well, after I had to go into the field and flip back and forth between 3 sheets, I was like, this is a bad idea. So put as much information on each plan as you can and make it as simple to read as possible, I would say, if this will work. Okay, this is just an example of a shear wall. So this is our perforated shear wall. So you've got hold downs at each end. We're showing that there's blocking. It's not force transfer. You don't need all the extra straps and all of that, but you want to convey the information clearly. So we're pointing out what all of the elements are on this, that when you go to our, and then this is just a segmented wall with the same thing. The lower portion of this slide is our shear wall schedule. So we have the mark, we have the spacing, and then the nailing. We're going to be changing this recently with the new NDS to actually just say diameter and length of nail rather than 8D. This again is another picture of our shear wall. What I want to point out for this is very important, what I've highlighted. So typical for our shear wall nailing. One of the things that I see a lot is that the nails are overdriven, right? And once they're overdriven, and I'll get into it, there's criteria of how much capacity you have left in your wall, if any. So what I tend to do is have a pre-construction meeting with the GC before they start putting on the exterior sheathing. And this is for a bigger project, not necessarily a house. It can be just a phone call if it's a house, right? And just lay out the expectations and say, you know, we've seen overdriven nails a lot and it's a big deal for us. So make sure that your framer has their nail gun set appropriately. And it's always better for them to be sticking out a little bit. And I know they don't like to do it, but then they can take their hammer and drive it flush. Now, as a former framer, I would never want to have to do that. So I would make sure that my gun was set right. Just some other typical things that you want to look at is that in this photo here, you can see this was a multifamily project where that's a party wall. So they've got the sheathing on one side, they're gonna have to come back and do the sheathing on the other side later, but I make sure that they have all their blocking in for the panel edge nailing for when the second set does have to go in. So that's a multi-step project or multi-step process, right? Where you have to go back and forth to the field many times. What I would say is, what I try to do is we do fixed fee through CD. And then for projects such as this, we like to do CA hourly. This particular job, my CA fee exceeded our entire design fee because the contractor kept calling us out. If that's not an option, because I know some people are going to say, I'm not just going to give you an open checkbook, right? Make sure that your scope is clearly defined in CA, where you specify the number of site visits that you have included in your fixed fee. So if you have to go out more times, then you can ask for more money for that. So you're just protecting yourself so that you don't have to just, you know, lose tons of money. There's different types of sheathing that you can use, right? Plywood OSB, they're the same. Zip, there's two different things for zip, right? There's zip and there's zip bar. When I say zip, I like the zip structural sheathing. We're talking to an architect, they want the insulated one. There's a big difference between the two. Zip R or zip, regular zip is essentially the same as your structural sheathing. There's no reduction. So you can just, if they say, can we use this instead of this? The answer is yes. If they say, can we use zip R instead of your 3-inch nailing that you've got on your OSB? The answer is absolutely no. But like what I have seen and what we did on one project is 155-mile-an-hour wind. They wanted zip R. So they ended up doing both. They did OSB on the entire outside of the building. We did the observation. Then they came over and did zip R on top of it. I don't know how cost effective that is, but it was what the architect wanted in order to get their continuous insulation and their vapor barrier. So keep that in your back pocket as an option. Zip R, what I've got highlighted, which you cannot see because I can't see it unless you've got really good eyes, is look at the aspect ratio that's allowed for zip R because it's different. This says 1:1. It used to say 2:1. I just grabbed this ESR a couple of weeks ago. So I don't know if this is a typo or not. But so if you are using zip R, one of the things to consider is that your, and I know you said you have to leave soon, so I won't be offended if you get up. Okay. The aspect ratio of zip R puts you more in as if you were designing for seismic, right? So you don't have that 3.5:1 aspect ratio that you do. You've got either a 2:1 or a 1:1. So if you've got a 9-foot tall plate, you're going to have a 9-foot piece of wall in order to even count on that as a shear wall if you're using zip bar. Now it might be 4.5. I think this is a typo, but maybe it's not. So do your own research and dig into that. Check the depth of the nail heads. I had a project that was in Yellowstone. So 100-pound ground snow load, seismic design category D. It was a big deal. And these were modular buildings. So they were building them in Boise, I believe, shipping the boxes to site and stacking them. Well, when the first set of boxes got to the site, we were seeing that 90% of the nails were overdriven. They had to replace a whole bunch of sheathing. The photo on the right shows that that was too much. And I'll get into what's too much and what's not in a second. But if it's a 1/16 of an inch, you're okay. Don't even bother with that. If it's an 1/8 of an inch, then you've got some problems. So what I do is, do I bring a pair of calipers out there? No. My rule of thumb is that when I put my finger on the hole, if my finger can touch the nail head, it's okay. If it can't, then I start looking at it a little more closely. This was a project in Boulder, so this is zip, not zip R. You can see that the photo on the left looks pretty good. The photo on the right, there's a whole bunch of overdriven nails. There's some plywood OSB that's blown out on the top. If you're gonna go to the site and document stuff with photos, what I do recommend too is use something as a scale item. So that's why that pen is there in that photo. So when I get back to the office, I have some sense of how deep that really is. So I would have, this APA technical topics, I'd recommend that you all go grab it. I couldn't put a link on this. I would have. It's a free document, but you have to create an account and then they'll give it to you. There's some guidance in this as to how to address overdriven nails. In summary of it, the key points are if everything is overdriven by a 1/16 of an inch, it's fine. There's no reduction. If you've got 1/8 of an inch overdriven nails and no more than 20% of them around the edges are overdriven 1/8 of an inch, but then that means that you can't have the 1/16 also in addition to it. It's just 1/8 inch now. If on 20% or less, then they're saying that there's no reduction as well. So this is a great document for all the engineers in the room. I'd recommend that you grab it, read it. It helped me out a lot on that Yellowstone project. Okay. What this slide is showing is, you know, we talked about hold downs, right? We're engineers, so we throw in hold downs everywhere now. They're necessary when you're in high wind. If you can do the IRC method, which I don't, because I usually am not in that luxury where I'm in a wind zone where I can even do it. And if you look at it, it's a prescriptive method, right? So if you meet X, Y, and Z, you have to meet X, Y, and Z in order to use that criteria. You can't say, oh, I'm close with this, so that's good enough. It's a prescriptive method. If you were to run the numbers on it, you would be hard pressed to try to make it work. So either you're doing the IRC and meeting all of the requirements of the IRC, or you as the engineer of record are designing the lateral system and taking responsibility for everything. When I go in the field, I always check all the hold downs. So I take my plan with me and I check every one. I circle ones that are not there or not installed properly. One of the things that I would recommend that you, if you are going in the field and you've got like an HDU2 or an HDU5, you know, you've got the nut on it, 5/8 inch diameter for those, check the nut, make sure it's tight. If it's not, then I check every single one of them. And 90% of the time, they're not tight. So just something to be aware of. And inspectors, please check that too. Okay, so like I said, just a big high level overview. Things to look for. Make sure your drawings clearly define what your lateral system is and what's important and that they can build it. So that's just kind of a high level of what I see when I'm in the field. And these slides, it's my understanding, Greg, will be available for everyone, right?
Yes. Yes, we will do a PDF of the presentation, make it available. And Eric is going to put the recording on his website. So it's in 2 places.
And when you go out in the field, remember, don't look at just all the engineering. You can take a picture of the mountains. Any questions for any of us?
For in Boulder, do you use portal frames at garage doors? Since it's in the IRC, but it's outside that 140 allowable. No. You don't prescribe.
The portal frame, that is, again, it's a very prescriptive thing. If you're above the 140, you can't use that portal frame. I have to go to steel moment frames instead when I do that.
And then circling back on the nails, as you do these inspections or observations, do you take a look at the nails during your observations and see if they're using the right ones? We do a ton of observations in Boulder and we find that they're commonly not using the 8 penny commons.
Yeah, so I mean, what we so our drawings say 8 penny, but we define that 8 penny as a 0.13 or 113 by 2.5 or whatever. And when our shear wall tables, what we do, we list, I don't know if you noticed, we list the actual capacity of the shear wall. If you look at that versus what's in the NDS, it would be lower because I know that they're going to be using gun nails typically. So a rule of thumb is that it's about a 0.85 reduction for gun nails. Each manufacturer is different. That's based on one specific manufacturer. But we take a reduced capacity in our design, so because we know they're going to use it. They're not going to be doing 8 penny common hand drive nails in the field. Now, there are different gun nails that you can meet the diameter and the length of certain nails. So that's why we're going, Paul, this is news for you. We're going to move towards just specifying diameter and length for everything, including our shear wall schedules. That's what is common for roof sheathing and for wall sheathing. Yeah.
One final follow-up on that, do you tighten the field spacing from the 12 inches on center with those?
No,
reduced
because
capacities?
when you look at that, it's always 12 inch in the field. What we care about is the panel edge. That's what you're getting all of your shear resistance from mainly, is that panel edge. Yeah.
So when I see a plan that's in a wind zone greater than 140, but the reference on the plan is to like an IRC table or IBC table for fastening, am I to assume that the engineer intentionally did that and knows that that fastening may not be what they're?
So technically, once you hit the 140, so at 140 and above, IRC is out the window. You shouldn't be referencing the IRC. You should be referencing the IBC. And the IBC references the NDS and the SPIDWIZ. So I mean, I would say most of us in this room, I would guess, are looking at those NDS values, but that's just a guess. Anything else?
So a lot of the time I will see a reference to an IBC or IRC table. So
IBC is okay because IBC is referencing the NDS.
Okay.
SPIDWIZ.
Okay.
And why they call it SPIDWIZ, it's because it's easy to say. It doesn't make any sense when you put the letters together. Yeah, Paul.
So one thing on the Zip R, I don't know, it's a little bit newer of a product. If you guys have gone out there and looked, if it is overdriven more, it does start to blister and crack. And so that's a big thing too. If it's out there in the weather, they want to tape that real quick. So it's important to get the observations once they drive them, because if it's sitting out there all winter and whatever else with the rain, it blisters. And then all of a sudden you're over that 16th, eighth of an inch. And then they start putting more nails in, and now they just got to rip off the whole panel and start over. So.
And that APA document that I referenced, it does talk about, it can be overdriven more than a 16th if the OSB has been wet or the OSB is thicker than what you designed. So there's great information in that. To Paul's point though, when any zip, whether it's Zip R or Zip structural sheathing, they want to get those seams taped as quick as they can. So that's why that one job, when I said I exceeded the CD design phase with just CA, it's because we had to go to the site probably 30 times. But now this was a fourplex and a twoplex. So that was over the course of 2 buildings. And that was for every element. That was foundation through going 4 times to look at one shear wall, because the first time was they drove everything. The second time they kind of fixed it. The third time I had to go look at the second side of the plywood because it was a double-sided wall. And the fourth time was because they had to go back and look at it for the corrections that they needed to make for that. And then what we'll do is in Boulder, I don't know what it's like in Larimer County here, but in Boulder, in the end, we as the engineer of record have to write that compliance letter that says that there's a lot of weasel words, just so you understand, is that it is in general conformance with the design intent of the contract documents. You know, that sort of language, we're not certifying that it was built 100% correct, because that is a contractor's responsibility, but we have a high level of confidence that they've done it right. Right. And I know we're about out of time and people have to get to parking in 15 minutes. So I don't know if there's any other questions. Well, thank you everyone for your time. It's been a pleasure being here.
Just to repeat a couple of things. First of all, I hope everybody signed the sheets out front. That's how you'll get the PDH credits for this. It's also how you're going to get a PDF of the presentation. I think I'll just send those to everybody, little electronic file. And then remember, I don't know what, a week or so, Eric, that will probably be on your website. Okay, so if you want to listen to part of the discussion, you can get in there and look at that. And it's Eric's intent to be able to use it in the future if this comes up in training and that sort of thing. Did this meet your expectations? Good. Was there something we should have covered here and we can do it in the future on this same subject? Light wood framing. Yeah.
Give them the permit, hey, go check this out on lateral world.
I mean, there are some training available either through APA or ICC or other professional organizations. Right. Well, we don't have any kind of mandatory training or make people go through stuff. For the general contractor, they have to be licensed, which means they have to have experience and be certified. But it's been said anyone with a pickup truck and a hammer can be a framer. So some are better than others.
And do take advantage of the ICC and the APA videos they're pretty good, for somebody that's not, well, for engineers as well as non-engineers. So there's a variety of stuff. All right, so no suggestions on furthering this subject, light wood framing. If you have them, send me an email. I'll be glad to look at it in the future. Any other burning topics that you guys have right now in the city of Fort Collins? Northern.
Yeah, during the plan review, we have a form we fill out what special inspections are required. So if it is a requirement, you wouldn't get the final approval or CO unless we had verification that you guys had done the structural observations or other approved special inspectors had given us the information we needed.
And last but not least, if you're interested in this group, in the subject, go on the SEAC website, get signed up to be a member of SEAC Northern Colorado Committee. Again, we meet once a month, combined with Denver every other month, and then we do our own thing, each alternate month. And the subjects vary a lot. It depends on the interest. It could be something as simple as touring a batch plant, which we did I don't know, a couple of months ago. And obviously that brings out a lot of people that you'd like to meet, that being students that are coming out of school. I'm sure you guys wouldn't mind meeting a bunch of graduating seniors, right? So it's a mixed crowd. There's from students to old guys like me. So get involved. And I guess last but not least, if you get tapped on the shoulder by a guy like Eric Freed or any of the jurisdictions that would like your help on one of their code committees or some problem, do it. It really helps the relationships.
If I
Yeah.
could add one thing, and we really value our relationship with SCAC Northern Colorado and the engineers and design professionals we work with. There's also a bunch of architects here, which is great. We'd love there to be an AIA Northern Colorado committee, so maybe you guys could form one and start having meetings on your own as well.
You can come meet with us. All right. With that, that is the conclusion, unless somebody else has something else. Thank you. Thank you very much.